Welcome to Spring LIB.
In this problem, we are told that we have a concentration cell with a silver electrode and Ag plus aqueous ions. And so therefore, we know that this is the half reaction that is taking place. And in the anode, we have oxidation. So we have Ag solid, that silver electrode with an oxidation state of 0, going into Ag plus an aqueous solution. And at the cathode, we have to be undergoing reduction. So that means Ag plus gains an electron to go to the solid state of the silver electrode. And based on the information in the problem, we are given the value of the concentration for Ag plus ions in the cathode. And in part A, we want to determine the same for the anode. So we know that these are the two half reactions, the same half reaction taking place since this is a concentration cell. However, one is undergoing oxidation and the other one's going reduction. So when we add them together, we see that the one electron cancels on each side and solid silver cancels on each side. So our overall reaction is Ag plus, which is at a concentration of 0.10 molar, going to Ag plus at an unknown concentration that we need to determine in part A. And the overall standard cell potential is equal to 0.00 volts. So in part A, we use the Nernst equation in order to determine the value of the concentration of Ag plus ions in the anode. So the cell potential is given as 0.76 volts at non-standard conditions. We know at standard conditions, the cell potential is equal to 0 volts. We subtract 0.0591 over N is equal to 1 electron based on the half reaction. And then we do the log of Q. And Q is equal to the concentration of Ag plus in the cathode over the concentration of Ag plus in the anode. So that is the unknown concentration that we are solving for in the numerator divided by the given concentration in the cathode. So we can call that the concentration of Ag plus, the variable that we're solving for in the anode, divided by the concentration of Ag plus in the cathode, which is given as 0.10 molar. And now if we rearrange this equation to solve for the concentration of Ag plus in the anode, we should find that value to come out to about 1.0 times 10 to the negative 14th molar. And now in part B of this problem, we want to determine what the equilibrium constant is for the reaction Ag plus aqueous plus 2S2O32 minus aqueous going to Ag S2O3 2 3 minus aqueous. And we know that for any equilibrium constant expression, we can write this out from the aqueous species, and all of them are aqueous in this case. That's equal to the concentration of Ag S2O3 2 3 minus divided by the concentration of Ag plus times the concentration of S2O3 2 minus squared. And now we are given the concentration for AgS2O3 3 minus to be 1.0 times 10 to the negative third molar. And the concentration of Ag plus is a concentration in the anode that we solved for in part A, which was 1.0 times 10 to the negative 14 molar times the concentration of S2O3 2 minus, which is given to be 0.050, and we square that term. And now when we calculate out that ratio, we find that the equilibrium constant K for that reaction is equal to 4.0 times 10 to the 13th.